Algebra 2, Common Core, solving rational equations, basically fraction equations. And there's a couple of types. Well, this type is called a proportion. Whenever we have a single fraction equal to a single fraction, that is called a proportion. And you can solve proportions, which you've been doing for many years whenever you've had equivalent ratios and different things like that, through cross multiplication, which most people like. So we could just cross multiply here and equal to it, cross product over here and solve. And that's ultimately what we're going to do. But a lot of these rational equations look like this, or like these two over here, where you can't cross multiply this because it's not a proportion. It's not a single fraction equal to a single fraction. But this first one is, so let's do that. But one thing I want to point out is, notice, always take a look at the denominators before you do anything. And like in this example over to the right, my denominators are 2 and 6, and I could think of that as a denominator of 1 if I want to. But over here I have a x as an expression in a denominator. Anytime you have a variable denominator like this, you have to state the value of x that you're restricted. See, when it comes to, radical equations, which was a previous video, square roots couldn't equal negative, right? And so we had extraneous solutions possible. Well, the same thing happens with fraction equations and logarithmic equations and different types of equations. There's often things that we're restricted with, the values of x that we can't get. And for fractions, it's all about an undefined concept that the denominators cannot equal 0. You cannot divide something by nothing. So it's not that x can't be 0, it's that the denominator can't be 0. So this down here, this expression, denominator expression that contains a variable, that expression cannot equal 0. And so I have to figure out what value of x would make it 0, and before I even solve the question, say, all right, well, whatever x comes out to be can't be this. And if that is my answer, I'll have to reject it. So the way to do that is to take that denominator, set it not equal to 0 because it can't equal 0, and basically solve it through. So I could subtract 1, just like if it were an equal sign, and divide 2, and I get that x cannot equal negative 1/2. And this is actually part of the answer. It's not what x can be, but it's what x can't be. And that's important whenever you have a variable down there. Now, for this next question over here, I'm not going to have to do that because there's no variables down there. But this one I won't, but this one I will. But I'll get to these questions in a moment. So just always look out for that, and don't forget that step if you have that. Now that I got that out of the way, I'm going to solve. If I get x equals negative 1/2, I'm going to have to reject it. But you want to do that first. All right, so let's see here. Cross product. The cross product of 3 and x is 3x. The cross product of 4 and 2x plus 1 is 8x plus 4. I can subtract 8x, get negative 5x equals 4, and divide by negative 5. So x equals negative 4/5 when I do the division, and that's my answer. And I could plug it back in to check it. But because it's not negative 1/2, I know it's not going to reject, but that's about it. It comes out to be a fraction answer. That's okay. A lot of these are not fraction answers, but this one happens to be. But when it's a proportion, just cross multiply. But always don't forget to state the value x can't be if there's a variable denominator. All right, how about the equations that are not proportions, the ones that can't be solved with cross multiplication? We're going to use a method in this video called clearing out denominators. And it's a very effective method. It is not the only way to solve these questions. You may be taught a different way to solve this. You may like a different method here. It's actually possible to create a proportion and cross multiply. There's so many different ways to solve this, LCD methods. This is about one specific method, and that's all this video is going to cover. But I really want to make that disclaimer that this is not the only way to solve this type of question. You can solve it many different ways. Clearing denominators basically is a method that we don't like fractions. I want to solve an equation like this with no fractions. So I'm going to try to create an equation that has no fractions. And the way I'm going to do that is I'm going to multiply out denominators one at a time. So I have a denominator of 2 here. And so the way to get rid of that is multiply everything by 2. So I multiply everything by 2. What's the result? Well, the term that I'm multiplying by 2 that had it, that simplifies that denominator right there. And all I'm left with is x plus. The second fraction here is 2 times x divided by 6. I could write that as 2x over 6 but it's a better idea to simplify this as you go if you can. Before I do the 2 times x, simplify the number you're multiplying the top by and the denominator that's present. And 2 and 6, I can simplify them both by 2, so that really becomes 1 and 3. So this expression, instead of 2x over 6, I'm going to write it as x over 3 equals 2 times 2, 4. Did I have to do that there? No, but it's going to make the problems easier for you if you simplify along the way, if you can. Sometimes you can't. I have one denominator left. I'm going to do the same thing. This denominator of 3, to get rid of it, I'm going to multiply everything by 3. So multiply that by 3, multiply that by 3. That gives me 3x. Here my 3's cancel out, so I have just plus x equals 3 times 4, 12. And now I have an equation with no fractions. I could just go and solve it through normal methods. 4x equals 12, x equals 3. And I could plug it back in to check it. There's no restrictions here, so I don't need to worry about extraneous. All right, let's try just a couple more examples, but that's basically going to be it. All right, so this one, first I'll multiply everything by 3. Multiply by 3 and times 3. Here they'll cross out. I have x plus. I can't simplify this expression here with what I'm multiplying, so I do just multiply the top. 3x plus 3. That was an expression that required distribution, so watch out for that. Whenever there's expressions, don't forget to distribute. Equals 3x. All right, now I'm going to multiply everything by my other denominator 2, so times 2, times 2, times 2. Here I have 2x from this one. This one, they cancel out, so I have just the plus 3x plus 3. And here is 6x. 5x plus 3 equals 6x. 3 equals x, and we're done. Not bad, right? Okay, one more. Let me multiply out this 2 here. So times 2, times 2, times 2. These cancel out. I'm left with 1 plus. I can't simplify this times 2 and x minus 2. That doesn't work out that way because this is an expression. I'd have to have an x minus 2. So I can't simplify anything here, so all I can do is multiply the top and keep the bottom what it is. Equals 3 times 2, 6. All right, one more denominator down here. Multiply everything by the denominator x minus 2. X minus 2. X minus 2. And notice that this was a variable denominator, a denominator that had an x. So what I actually should have done before I started the problem was say that x cannot equal 2 as part of my answer, because that's what would make this 0. So it's easy to forget about that. You have to, if you do it in the beginning or halfway through the problem, I realized I'm multiplying by something with x out. That kind of reminded me that I needed to state that. So you got to always remember that. That is part of the answer. All right, so here I'm multiplying. This is x minus 2 plus, this cancels out, so plus 10 equals 6x minus 12. And at this stage, once you get it down to be a single equation, it could be complex from there of varying degrees. It could be something that requires factoring, completing the square, who knows. These are pretty basic examples. This works out to be x plus 8 equals 6x minus 12, but you solve it through normal methods. Subtract x, 5x, add 12, 20, x equals 4. And you can certainly plug this back in to check your work, which is a good idea to do. I'm not doing that for all these just to save time in the video, but let's check it on this one. If I plug in a 4, my equation was 1 over 2 plus 5 over, now if x equals 4, 4 minus 2 is 2, and that equals 3. And 1 over 2 plus 5 over 2, they have common denominators, so you can add them together to be 6 over 2 equals 3, and 6 over 2 does equal 3. So it's worth it to do a quick check, make sure you have the right answer. So in a proportion, you could just cross multiply. That's nice. But the ones that are not, that have multiple denominators and multiple fractions, if you multiply them out one at a time, sometimes simplifying as you go, sometimes stating a restriction for your denominator, things like that. Careful with the algebra, check your answer. And that's how we solve rational equations. See ya.